Hello guys, last time I made a video on gravitational potential energy where I used this formula to derive the formula for gravitational potential energy. That is the formula of gravitational potential energy, which is what? The integral of from infinity to a point r, integral fx dx, okay? Where fx is equal to what? Gmm over x squared. So I use this formula to derive the formula of what? Potential energy. That is the gravitational potential energy, which is the work done in taking a mass from infinity to a point r. Okay? Now, potential energy is defined as the work done. Now, let us emphasize on that. Work done, work done is equal to what? Force times distance. This is the expression, the mathematical expression for work done. Okay. Now, this work done can also be defined as a change in what? In kinetic energy. So that is work done is equal to what? A change in kinetic energy. Okay. A change in kinetic energy. The work done. This is delta. Okay. Change in kinetic energy. Yes, and it makes sense to define work done like that, because for a particle at rest, if you move that particle from that point to another point, do you understand? A work is being done. Do you understand? Because there is a change in what? Kinetic energy. Initially, the kinetic energy is zero. So when you are doing the work, there is a change in what? Kinetic energy. So that is it. Now, remember that the gravitational field is a conservative field. That is a conservative field. And the gravitational force is a conservative force. What is a conservative force? A conservative force is a force such that the work done by the force between 2 points on the field is independent of the path taken, that is independent of the path taken in the field. That is between any 2 points in the field. The work done is independent of the path taken by the particle. You will not say that because the particle took one path, the work done is lesser than the if the particle took another takes another path in the field, in the gravitational field. Do you understand? Yes, so that is it. So the work done is always what? Constant. Okay. So from this perspective, and from the perspective of the fact that gravitational field is a conservative field, it means that the total energy is what? Constant. That is kinetic energy. Kinetic energy plus what? Potential energy is what? Is equal to what? Constant. Is a constant. That is the total energy. Is constant. Okay. Yes. So let me just write it equals to constant. So also we can say it in this way, that the change in kinetic energy plus what? The change in potential energy is equal to what? Zero. The change in kinetic energy plus the change in potential energy is equal to zero. So which implies that the kinetic energy, the change in kinetic energy is equal to what? Minus change in potential energy. Okay? Change in kinetic energy is equal to minus change in potential energy. So now, change in kinetic energy, remember, work done is defined as change in kinetic energy. So change in kinetic energy is what? The work done. Okay? Which is equal to what? Minus change in what? In potential energy. Okay? So that is it. So that means that change in potential energy, the change in potential energy is equal to what? The negative of the work done by the what? The gravitational force. Change in potential energy is the negative of the work done by the gravitational force. You see, this equation is very, very important. So, potential energy is given by the symbol U. So that means that U is equal to what? Minus W. U is equal to minus W. Some put it like this, minus WD, that is work done. So now I don't want this video to be long. In my next video, you will now see how I will use this equation that the work done is negative of change in potential energy. Okay, I will use it to derive the formula for potential energy. Do you understand? I will use it to derive. So the work done, as using the work done being change in potential in that is negative of change in potential energy to find the formula of what the change in what in potential energy. Do you understand? That is gravitational potential energy.